All right, today we've got a really cool story. It's about a superfood that's taking off, but it has a pretty tricky problem. And the solution involves a really unique kind of AI. So let's just dive right in.
So, this right here, this is the Barro almond. It's this amazing superfood from Brazil, a total powerhouse of nutrition. But it's got a secret challenge. See, unlike the stuff you see in perfectly uniform packages at the store, these things are, well, they're all over the place. No two are alike. One harvest, they're one size. The next, they're completely different. It's a real headache.
So that begs the question, right? How in the world do you sort them? If you can't rely on them being the same size or shape, how do you consistently figure out which ones are top quality and which ones aren't?
And believe me, this isn't just some minor inconvenience for a niche product. The stakes here are actually pretty high.
First off, the Baru almond is a legit superfood. We're talking more protein than most other nuts, packed with fiber, minerals, the works. It's also a huge deal for local farming economies in Brazil. And check this out. The global market is projected to hit nearly 50 million bucks. So yeah, being able to guarantee quality, that's not just nice to have, it's absolutely crucial.
So here's the core problem, the thing that started this whole quest. Scientists have a fancy term for it: significant morphological variability. All that means is that the nuts are all different shapes and sizes. It's like trying to sort a bag of random pebbles. And the old ways of doing things, someone eyeballing them, or a clunky machine set to one specific size, they just don't work. It's slow, it's subjective, and it's super inefficient.
Okay, so this is where the solution gets really, really clever. Instead of trying to force these unique almonds to fit a rigid system, some researchers decided to flip the script. They brought in a special kind of AI that's designed to think, well, a little more like a human.
It's called fuzzy logic, and it's not as weird as it sounds. You know how normal computers think in absolutes? Yes or no, true or false, 1 or 0, black and white. Well, fuzzy logic is all about the shades of gray. It's designed to handle concepts that are a bit, fuzzy, like kinda big or a little heavy. It's built to deal with uncertainty.
Okay, look at this. This makes it super clear. A standard computer program would draw a hard line, let's say at 10 millimeters. If an almond is 9.9, it's small. If it's 10.1, it's medium. End of story. But that's not how we think, right? We know that 9.9 is really close to being medium. Fuzzy logic understands that nuance.
Exactly. It thinks in categories that overlap, just like we do. An almond isn't just a number. In a fuzzy system, it could be, say, 80% middle and 20% large. And that ability to see things on a spectrum is what makes it so powerful for a problem like this.
So that's the big idea, but how did they actually build it? Let's break down how this system works.
This diagram gives you the whole bird's eye view. Over on the left, you start with your inputs, the physical measurements of the almonds, and, crucially, the knowledge from experts. All of that goes into this fuzzy logic engine in the middle. And what comes out the other side is one simple, powerful number, a quality score.
It really boils down to 3 steps. First, you have fuzzification. That's where you take the hard data, like the exact weight in grams, and turn it into fuzzy terms like light, medium, or heavy. Then comes inference, where the system uses a bunch of if-then rules, kind of like a human expert would. And finally, defuzzification, which is a fancy word for taking all that fuzzy reasoning and crunching it back down into a single concrete quality score.
And what are those hard numbers it starts with? Just 4 simple things: the almond's diameter, its width, its length, and its weight. That's the raw data that gets the whole ball rolling.
Now this is the magic right here. This is the brain of the operation. It's a bunch of simple if-then rules that are programmed in based on what human experts already know makes a good almond. Look at Rule 1. If the weight is heavy and the length is long, then the quality is high. That just makes sense, right? Or Rule 3. If it's slim or short, then the quality is low. The system just applies all these common sense rules at lightning speed.
Okay, so the system seems pretty smart on paper, but the real question is, does it actually work in the real world? Let's see what happened when they put it to the test.
So check this out. On the left, you have the quality scores from the 2012 harvest, and on the right, from 2013. You don't have to be a data scientist to see the difference. Look at 2012. The scores are more spread out. Now look at 2013. See how that hump is shifted to the left? That means a lot more almonds fell into that lower quality range that year. The system was actually seeing the year-to-year variation.
And this bar chart just sums it up perfectly. The average quality score for 2012 was 43.5, while 2013 was down to 41. So it wasn't just a hunch that one year was better than the other. The system proved it. It put a hard number on it.
And this really gets to the heart of why this is so cool. The researchers themselves said the model can differentiate gradients of physical performance. What that means is, it's not just a simple thumbs up or thumbs down. It's not just good or bad. It gives you a score on a scale, so you can see the entire range of quality. The amazing ones, the pretty good ones, the okay ones. And that's way more useful.
So let's zoom out for a second, because this is way bigger than just one type of nut. What we're looking at here is a potential blueprint for a much smarter way of doing agriculture.
Just think about the benefits. It's fast, it doesn't damage the product, which is huge. It's transparent. You can actually look at the rules and understand why it made a certain call. And maybe the biggest win of all, it is completely consistent. It takes human error and subjectivity right out of the equation. That is what precision agriculture is all about.
And they're not done yet. The next logical step is to hook this system up to digital cameras. You automate the whole measurement process. Just imagine it, a machine that can see an almond, instantly measure it, and give it a precise quality score. Over and over again, thousands of times an hour. Game changer.
And that leaves us with a really big, thought-provoking question. So much of our food, so much of nature is wonderfully inconsistent. It doesn't fit into neat little boxes. So what would happen if we started applying this kind of fuzzy, more human-like thinking to everything else? To apples, coffee beans, avocados, you name it. It could completely revolutionize how we grow, sort, and value our food.